The world around us is changing at a faster pace than ever before, and in terms of the environment, many of these changes are not for the better. Despite the threat of irreversible climate change, fossil fuels still account for over 90% of Ireland's energy supply. And with natural resources dwindling rapidly, this figure represents a crucial and urgent challenge for us.
While it might be convenient to point the finger elsewhere, we are all to blame. Irish homes are responsible for generating 6 million tonnes of carbon dioxide every year.
Many households are now choosing new ways of improving the efficiency of their homes. One such household is the Quinn family. When the Quinns built their new home, they implemented a number of measures to use energy as efficiently as possible. For example, the house features a large southwest-facing double-glazed floor-to-ceiling window to make more of the warmth from the sun. They also installed a mechanical ventilation system that removes the warm, damp air produced by showers and cooking and uses it to heat the fresh air coming into the house. But how do they heat the house itself?
I suppose this is what we'd call the nerve centre of the house, you know. Basically outside we have a heat pump, and very simply the heat pump extracts energy from the air that's outside. That energy is sent inside to this 1,000-litre tank and heats all our hot water.
So all the heat that you need for the entire house you get from outside there?
Absolutely. My wife Marion was very sceptical about how this system will actually work. She wasn't convinced by not having an on-off switch, radiators, immediate heat. This system works in totally the opposite way. It's low temperature heat over long periods of time, and 3 years down the road, we wouldn't turn back. We're delighted with the system.
It is nothing short of miserable out there, but in here, it's practically tropical. So how exactly do these heat pumps work?
I'm here at the Global Energy Research and Development Centre in Dunleer to find out.
Solar power is all around us. We're getting more in 1 hour than we could possibly consume in a whole year on planet Earth. Solar energy is heating up the air, the water, the ground that we're standing on. And what we're talking about doing is extracting that energy around us, and we're transferring that heat into our heat pump cycle. We're compressing the gas that's carrying it, and that's raising the pressure and the temperature. And on the other side, we're extracting that heat out and pumping that heat around the house to heat our underfloor systems or our hot water and getting heat into the home.
Sure, I can see how that would work in a place like the Maldives or Malta, but here in Ireland, would that really work?
Yeah, it works in Ireland because we only need a very small amount of energy to take out of the environment. It works in climates as extreme as Siberia, where heat pumps can work right down to -25 and up as high as 30 degrees Celsius.
In a heat pump, the evaporator takes the thermal energy from the environment and transfers it to a refrigerant. By increasing the pressure on this refrigerant, the compressor causes the temperature to rise. This heat is transferred to the heating system inside the house. The refrigerant then cools down before it returns to continue the cycle. In fact, the exact opposite of this principle is something we use in every kitchen in the country.
A fridge works in exactly the same way, except it's in reverse. If you open the fridge, it's cold inside. That's because we've taken any energy out of it or heat out of it. And at the back of the fridge, it's quite hot. And that's exactly what we're doing at the heat pump, except it's working in the opposite way.
This is an Irish story in many ways, isn't it? Because Kelvin was from Belfast.
Yeah, Kelvin was one of the first people to capture the idea of a reverse heat engine, or what we now know as a heat pump. And he penned that idea in 1852. And that concept is now all over the world being used to save not just energy, but also carbon.
This technology has already been put to the test, not just heating homes, but an entire hotel.
The initial catalyst was maybe the need in 2007, 2008 to try and find solutions to the economic challenges. But then as we looked into that further and were able to see that there was actually environmentally friendly ways to do it, you're obviously going to embrace that as well. Not alone does it only heat the rooms, it gives us all our hot water, gives our hot water for our leisure centre, heats our pool in the leisure centre, heats the jacuzzi, all the hot water for our kitchens. It looks after all of that, and perfectly well. The overall investment would have been about 220,000 in the heat pump project, but the savings that we're getting per year is about 40,000 euros for a hotel of our size. So it's very, very significant.
That's huge.
That, coupled with the environmental benefits, it was really a no-brainer for us.
With new EU targets for 2020, we're going to have to change our reliance on fossil fuels pretty quickly, whether we like it or not.
But with new technologies that allow us to extract the energy around us and save money, perhaps it's a change that isn't quite so daunting after all.